Hi, in previous lecture I discussed Kruskal algorithm. Let's discuss one example for finding minimum spanning tree by using both Prim's and Kruskal algorithm side by side that you can understand what is the difference between both. For Kruskal algorithm, I'll write all the edge weight in the sorted order. So 1, 2, 3, 4, 4, 5, 5, 6, 6 and 8. Let for Prim's algorithm, start vertex is A. From A will start. So A adjacent are B, F and E. Minimum weight is 3. A, B. So we'll choose A, B. And for Kruskal algorithm, minimum is 1. 1 is B, C. So we'll select B, C. Now in Prim's algorithm, AB is the subgraph with AB adjacent are C, F and E. BC weight is 1, BF weight is 4, AF weight is 5, AE weight is 6. Minimum is 1, so I'll choose BC. Now in Kruskal algorithm, next weight is 2. 2 is FE. We'll select FE. So you can mark here A, B, C are connected while in Kruskal B, C and F, E are not connected. So in Kruskal algorithm during the process it may not be connected but final tree will be always connected while in Prim's algorithm at every step it is connected. Next in Prim's algorithm with A, B, C adjacent are D, F and E. So CD weight is 6, CF weight is 4, BF weight is 4, AF weight is 5, AE weight is 6. So minimum are these 4. We can choose any 4, either we can choose BF or CF. Let me choose BF. Now in Kruskal algorithm 1 and 2 already done, next is 3. So AB weight is 3, that will choose. Now in Prim's algorithm with the subgraph adjacent are E and D. So here minimum is 2, FE. We'll choose FE. In Kruskal 1, 2, 3 is done, next we'll choose 4. We can pick any 4 either BF or CF. Let me choose BF. At this stage, both trees are same. Now in Prim's algorithm, A, B, C, F and E is done. Just D is left. So with C, D is adjacent, weight is 6. With F, D is adjacent, weight is 5. With E, D is adjacent, weight is 8. Minimum weight is 5. So we'll choose FD. In Kruskal algorithm, 1, 2, 3, 1, 4 is done. Next another 4. If we choose this 4, it will be a cycle, so we'll skip it. Next 5. We cannot choose this 5. If we'll choose this 5 AF, it will be a cycle, so we'll skip it. We'll choose FD. In the graph, number of vertices are 6. So in minimum spanning tree, number of edges will be 5. We already chosen 5 edges, so we'll stop here. We got our minimum spanning tree by using both Prim's and Kruskal algorithm. Here both structures are same, but both structure may be different. We chosen BF rather than BF, we may choose CF. Okay, so either we can choose BF or CF. Two possibility. Next there are 2, 5, but we cannot select AF. If we choose AF, it will be a cycle. So AF we cannot consider for minimum spanning tree. FD we can consider. We are not using any 6 weight or 8 weight. So due to these 2, 4, there are 2 minimum spanning tree possible by using both Prim's and Kruskal algorithm. In today's lecture, I explained one example with both Prim's and Kruskal algorithm. If this lecture is helpful for you, please like, subscribe and share. Thank you.